Hi, I'm Austin Liu of All Power Labs, and I'd like to give an introduction to the Power Pallet PP30 and explain how it works. So the Power Pallet is a biomass gasifier genset, and it consists of two half skids that we unite into one platform. On the right side here, you'll see a engine genset, and on this side you'll see a gasifier. And so what this machine essentially is a refinery united with a generation system. And between the two of them, we do a lot of waste heat recovery. So that enables the system as a whole to attain pretty high efficiency. So let's walk through the pathway of the feedstock, starting from the hopper all the way to the engine. So the Power Pallet, on the gasifier half of the Power Pallet, there are two main subsystems. On this side, you see the gasifier, and on this side here, this is the gas filtration system. Right? So the material starts out up here in the hopper and descends into the drying vessel. And the drying vessel recovers waste heat to dry out the feedstock before it is augered into this reactor. So this reactor over here is our 5th generation GEC reactor, and it basically carries out pyrolysis, converts all of that biomass feedstock into charcoal, and it combusts the tar gases from the smoke. And those combustion products are then percolated through the charcoal in the reduction zone. So the reduction zone carries out the reaction where the carbon, the hot carbon pulls the oxygen away from the water vapor and the carbon dioxide. Because hot carbon has a very high oxygen affinity, it will actually reduce water vapor back to hydrogen and in the process produce carbon monoxide. And that's basically what the gas is that comes out of this gasifier. It's a mixture of hydrogen and carbon monoxide, and since both of those burn fairly clean, that's what the engine is able to burn as opposed to solid chips of wood, right? Tar gases, of course, can't go to the engine because tar gases will gum up the valves. So this system actually exposes those tar gases to extremely high temperatures and cracks them all the way down to hydrogen and carbon monoxide. So in this reactor, those chips end up, those charcoal chips end up shrinking as a portion of that is turned into carbon monoxide. And they eventually get to the point where those chips are so small that they pack too densely to permit the rate of gas percolation needed to feed the engine. So the reactor will actually shake the grate basket and purge those little chips of charcoal, and that material then gets augered out into this vessel here. So this vessel is the char ash vessel. It holds about, I think, roughly 10 or so gallons, and that's the material that we end up using as biochar. Now, the gas then goes into the cyclone. In here, there's under this insulation, there's a cyclone, and that material spins out the fine particulates that remain entrained in the gas. And those dust particles end up in this cyclone can down here. And then the cleaned the gas then ascends this tube without all of the dust particles, and enters this heat exchanger. So this vessel over here is the first heat recovery stage on the Power Pallet. This vessel here cools the gas using the hot engine coolant. The reason we're doing that is that the hot engine coolant is hot enough to not condense out water, but it's still cooler than the gas coming out of the reactor. It comes out at roughly 500 degrees centigrade, and there's a lot of waste heat that's available in there. You can't mix gas that's that hot with air and feed into the engine. It'll just burst into flame immediately. So cooling the gas increases the density of the gas, and also cools out and condenses out a lot of the tar. And the tar at that temperature, when you condense it out without the water vapor condensing out, it condenses out in a sooty form. And this heat exchanger has these scrapers in there that scrape along the tube, and the flow of gas then purges those scrapings into the basin at the bottom here. The gas then ascends this insulated filter vessel, and there are filter bags inside here. There's 5 filter bags mounted underneath facing up, and the gases pass through those bags, and those bags capture all of the soot and all of the little bits of particulates that escape the cyclone. And the filtered gas then passes through this polishing filter. In the production units, this filter is actually inserted into the case on that side. And then the clean gas proceeds this whole system is actually passive. It's not producing gas under pressure and pushing it to the engine. The suction of the engine is pulling the gas out of the reactor. So the system is actually dependent on the suction provided by the intake stroke of the engine. Right? So let's take a look at the engine side real quick. So we've removed the side panel so you can actually see what's inside this engine compartment. The enclosure is new for this particular generation of the Power Pallet. But in this new generation of Power Pallet, we're using the Ashok-Leyland engine. It's a high compression spark-fired engine. The gas from a gasifier can't be used inside a diesel engine because it resists ignition compression, or compression ignition, I should rather say. So it still has to be spark-fired, but it still benefits from high compression because the gas resists ignition by compression. You can compress it a great deal before igniting it, and you can actually obtain a higher efficiency that way. So in this particular chamber, one of the things I'd like to point out here is that we have additional heat exchangers. So the PP30 has multiple heat exchangers. The first one we looked at on that side cools the hot gas. The second one here actually obtains heat from the exhaust. We route the exhaust to the reactor to use the heat from the exhaust to initiate pyrolysis and to maintain pyrolysis. That way we'll get a much more complete pyrolysis without cannibalizing heat from the combustion zone. So after the exhaust is done carrying out pyrolysis, there's still a tremendous amount of heat. It's still hundreds of degrees centigrade. And so the coolant, which is after it's gone through cooling the hot gas, then comes over here and cools the exhaust. And so there's a tremendous amount of heat available. And that then passes down. There's another vessel down here that's a little bit harder to see. It's tucked down here. And that is the heat exchanger for heating the external water circuit for the CHP function. So by that means the Power Pallet is able to provide 2 kilowatts thermal in the form of hot water for every 1 kilowatt of electrical load. Now the thermal output is tied to the electrical load because it's based on waste heat. You can't just produce hot water independently of the electrical load, but as long as you're generating electricity, there's sufficient heat to power the CHP system. Now in the Power Pallet 30, the fans are decoupled from the engine. And they're actually electrically run, and they're much more quiet because they're shrouded with little fan tip rings. Right? And the enclosure and the electric shrouded fans significantly cut down on the noise emitted by the machine. So I want to point out some of the features of the Power Pallet here. In the PP30, we have the grid tie controller as a standard feature. Previously, that was an item that had to be purchased separately, but also it was not possible to upgrade items which weren't purchased with it. And that was a frequent question we got: is if I purchase a Power Pallet, how do I upgrade that to having the grid tie controller? Well, the grid tie controller is actually fairly desirable, even if you don't connect the machine to the grid, because the grid tie controller enables you to synchronize multiple Power Pallets into a microgrid, or to synchronize this with any other existing microgrid that may have small-scale wind or solar on it. Right. So over here, this device over here is the PCU, and it carries out the monitoring of the gasifier. It reads the temperatures and the various pressures in the different zones, and if there are any alarm conditions, the PCU is the system that actually sounds the alarm. So that's the quick walk around the Power Pallet. The machine sits sort of at the intersection of biomass waste disposal, renewable energy generation, and biochar production. And in markets where you have all three of those things coinciding, that's the sweet spot for the value application. So if you have any questions or if you are interested in purchasing one, please email sales@allpowerlabs.com.